Hello all. Good afternoon. Yeah. So welcome to the session on securing the chains. So in this session, we will explore how different strategies and how you can secure your supply chains. So first of all, let me introduce myself. I'm a security engineer at CRED, and in the past, I did CTFs with Team BIOS, and I occasionally hunt for CVEs and all. So you can connect with me in this QR code. Cool. So let's begin. So agenda. We'll see what the software supply chain is, why it is important, and how not to build a supply chain security program. And we'll also see the evolution of a developer-friendly supply chain security program. So let's see what is a supply chain. So traditionally, what a supply chain would mean is the raw materials, is the vendor, is the processes, systems, and everything around it. So that used to be the supply chain, usual supply chain. Now let's get to the software supply chain. So in software supply chain, we can see that, as you can see, we have the input, that is the idea behind the source software, the code, the libraries, even the producers, like the developers, basically developers, contributors, all the third-party dependencies. So you can actually compare this to a traditional manufacturing level of supply chain. So there you would have the raw materials as like metals or the rubber, plastic, everything which could be used to build some actual material, right? So this is similar to that, but in terms of software. So essentially it contains these things like the developers, contributors, third-party vendors, dependencies, repositories, build systems, the pipelines, processes, and everything around it. So here, bill of materials. So this is something else which we should also take a look before going further into the presentation. So bill of materials is actually what are the things that are used to implement the supply chain or the end product. So it could be the dependencies that you use, or the third-party vendor tools. All those things that you use would be considered as the bill of materials. Cool. So let's go ahead. These are some metrics. So how many of you have faced some supply chain attacks? Cool. Yeah. So you can see, as you can see, 51% of JavaScript components are still vulnerable, have a known vulnerability. And if you take another example here, 13% of log4j downloads are still vulnerable. So how many people knows log4j vulnerability? Cool. Good number of people knows. Nice. So let's start. So one fine day, you end up in this situation, like log4j comes. How would you handle? So that is what this presentation would essentially solve. Yeah. So with the traditional approach, it would be a simple basic standalone tool or something that would help you to actually detect the log4j vulnerability or some vulnerability. So if you use a simple standalone tool, you would face many issues or many problems. Like it is not scalable, and you would have visibility issues, and instant results you might not get, history and tracking capability. So lots of these issues you will be facing. So that is why we built some tool called Supply Shield. So it is an open source project. So that is why we built this tool to particularly solve for all those issues you would face in an organization. Yeah. So this is our problem statement. So we are preparing for a 0-day, and we are looking for a solution that is scalable, ensures end-to-end visibility, and you get the instant results. You get to track the vulnerabilities and whatnot. You also get the clear action items. So we are looking for building something like this, right? So where should we start? So in order to find vulnerabilities, or in a huge company or in an organization, where should we start looking? It could be either in the source code, or it could be in the Docker images, or so any of this. So how many of you would say it's Git or the source code? Cool. Both. Cool. Okay. So here is how we started. So we chose to start with Docker. So why? So if we choose to go with Git, right, you won't have the visibility into the runtime installed correct exact versions of the package. Because let's say it's a Maven project, right? When you build, the versions of the packages might change. It might install something else, some other particular version. And you might not even get the full list of dependencies. So that is also a problem. So, like for example, if you take the example of a pom.xml file, you won't have all the dependencies that are dependent on particular one. So that is a problem. But instead, if you choose Docker, right, you will have the entire list because that is something which is going to be deployed. So it will have everything for that. Yes. So we get the exact runtime versions. We get the exact versions, and you could also get the vulnerable package because we have the exact versions available. You also get the both image and source code SCA issues. So here, SCA here, simply, let's simplify it for people who don't know. SCA is basically like vulnerabilities that are there in some package. So let's build some framework which is based on Docker. So here we have a simple process which does the Docker image based scanning. So developer writes code, pushes into the Git repository, and when you build, it fetches from the VCS and builds, right? And the image gets pushed into the ECR. Now we have some system, that is our automation, that will fetch the image and scans. So we use a tool called Swift. So that will generate the SBOM and push it to the S3. So here, if you remember the bill of materials, right? Here with this approach, you would get some live, like some SBOM, that is the software bill of materials, which you will be able to query in live. Like you can see what all the materials being used, like what all the dependencies being used. So all those things you would be able to see with this. Cool. So now we have the list of vulnerabilities and we are going to the dev, right? So you have to fix 256 vulnerabilities in your service image. Now developer obviously would be confused. Where should I start? So that is when we found out the first problem. That ownership of the SCA issues or the vulnerabilities lies with different groups of people. Like it could be the backend engineers, there could be vulnerabilities that were introduced by infrastructure team, someone else, right? So we had to sort out these issues. You cannot completely give it on the developer. Yes. So as we deep dived, we see that this is a Docker image. Yes. So this is a Docker image. And there is a base image also. And there is an application layer. So developer mostly, fetches the base image from, like you would have seen in the starting of a Docker file, from some image, some repository, / some image name. So developer basically imports that base image and uses, and he does not have control over top of that. So any vulnerabilities that are introduced from the base image should be fixed in the base image and not in the application layer. So basically the accountability of base image level SCA vulnerabilities would be completely on the platform team or the SRE team or the DevOps team. Yes. So how did we do that? How did we solve for that? So basically, let's take this example, right? There is a service image and it has 4 layers. Like a Docker image would consist of multiple layers. And this layer, if you can see, it is using some base image and you can see the hashes also, right? So the SCA issues, we can actually detect the base image from the service image using the layer hashes. So we implemented something based on the layer hashes. So, yes. So the SCA issues from the base image can be segregated using this layer hashing. Now we were given a problem to identify alien and outdated images. So basically, alien base images are, unapproved base images. Could be like something outside the org. Like, let's say I use some Python, some base image which is outside the control of DevOps. So that is a problem. And the second problem is some vulnerable version of the base image. So the DevOps team has fixed some vulnerabilities, but the developer has to upgrade that version in the base image also. So that is another challenge. So why is it a challenge? So unapproved base image is a challenge because of these reasons. Could be security risks, could be difficult for debugging, and reliability issues could be there. There could be also compliance related things over there. So that is why we should actually stop developers from using unapproved or alien base images. And there are also certain problems to it, like if we block the alien images completely. Let's go through each one by one. So maintaining inventory of all base images. So what is allowed? Like we have to whitelist, right? We have to whitelist and maintain what base images are allowed and what is not. So this is difficult and it would take some overhead. Then the existing builds, like let's say there is some deployed, already running services are there, those will get broken. And there would be pushback from the engineering team. This would essentially, slow down the development process, and it is not scalable in a fast-paced environment like in a startup. Cool. So let's see how we can find alien or outdated images. So if you see here, there is a service image and there are two base images. So you can see that this service image is using some layer A, layer B, and some other layers also. But the hashes do not match. So that means that this is completely relying on an alien image. So essentially we have to maintain the list of layer hashes in our organization and actually compare and see whether we are using a SRE or DevOps approved image or not. Then outdated base image. So outdated base image, we can actually track it using the layer hash system itself. So when there is a common layer hash existing, but there is a different version available for that, then in that case, we can say that the base image is outdated and the developer needs to be pinged, or developer has to upgrade that base image they are using. So that is how we find the outdated base image. Now let's say that developer has fixed all the base image related vulnerabilities. And now he is ready to fix the application level SCA vulnerabilities. So we go with him and says that there are 50 vulnerable packages in your microservice. And we hand out a list of 50 packages. So these are essentially package URLs or pearls. So this is a standard to actually show a package. And developer would come and say that these are not there in my source code. Like I did not install them manually. I did not do it. So let's again deep dive. Yes. So then we land on problem 2. That is pushback from engineering teams on patching SCA vulnerabilities. So there are 3 main challenges to this. Could be, identifying which package to upgrade, prioritization, and vulnerabilities from commons packages. Yes. So let's take a look at this, right? So here we have a service and it is importing 2 packages, and package A is importing another package. Now package A does not have any direct vulnerabilities, and package C has 2 vulnerabilities. Package B has 3 vulnerabilities. Now developer is complaining that they are not able to see why package B is being shown as a vulnerable package. Now this was a problem. So developer could not developer has to identify this is the root cause. This is the root cause. So that was causing a problem. Now how did we solve? How can we solve? So this is something called a transitive vulnerability. So we have a first level package and it is importing another package which is vulnerable. So this could be in many layers, right? So there could be n number of chains in it, and it is that one particular one would be vulnerable, and developer will say that I am not using it directly. I don't know how to fix that. So how do we fix this? So if you, in this case, right, if you look at the pom.xml file, especially in Java, right, you will not be able to see the package B, but you will see package A. So developer is not aware how to fix that. Yes. So this brings us to the need for better visibility. Here, SBOM had the capability to store relationships. So SBOM is a standard, and it had the capability to actually store the relationship. But the SBOMs which we generated, right, that did not have any relationships. Why? Because it was based on Docker. We created the SBOMs from a Docker image. So developer could not understand how the vulnerable package got introduced. Like, we were just giving him a list of packages which he needs to upgrade, but not sure how it got introduced. So the root cause was not known. Cool. So here we have our learnings. We are back to the slide. So Git and CDXgen. So CDXgen is an open source tool. You can try it out. And there is Docker. So if you use Docker, right, you will get the exact runtime versions, but you will not get the package relationship information. Like, you will not get the how that particular package was introduced. But you will get both image and source code level SC issues. But if you combine both this, that is the source code and CDXgen, right? CDXgen actually builds that service and then runs the SBOM generation. So it gets the exact runtime package versions. So you will get to know what exact version of package is going to be used. But if you just used Git, you will not be able to figure that out. You will also get the transitive packages and the relationships between each one of them. So that was an advantage over here. But image level, we will not be able to see in this case. Yes. So we use the combined approach to actually build the source code level scanning. So now the system is like, whenever Jenkins does the build, we send it to a queue and that message gets consumed by our tool. So that tool has the CDXgen, which generates the SBOM, and it pushes that into an S3, and it runs multiple steps on top of that. So basically, it's like a pipeline itself. Now we get the SBOM and we find the vulnerabilities and store. Now we have that relationships as we are using CDXgen. So let's see. Yes. Yeah. So if you see this image, right, you can see that package A is importing B and B is importing C. So all those relationships is being correctly shown. Now this functionality was not available in scan code. So actually what we did is we contributed, we went and added the capability to actually parse the relationships and store that in database also. So now we have the actual, paths in which the vulnerabilities were introduced. Yes. So you can, this is a very interesting project, you can try this out. Yeah. So our next problem was vulnerabilities from commons packages. So what is a commons package? So let's say in a company and in an organization, there could be functionalities that are shared among multiple services, right? So like, let's take an example of authentication. So the same package, some platform team or someone would be developing and they would be maintaining. But let's say it has some vulnerabilities. Who would be essentially fixing that? The maintainer of that. So basically, the maintainer has to actually maintain or actually fix that vulnerabilities introduced by that package. But how do we fix that? So let's take this example and see. So there is a microservice. It is importing the direct package and an shared package. So this is, or if you are not able to read, some com.company.package, and it has two vulnerable packages, which is, let's say transitively imported. Now, if I go and generate the SBOM, I'll get all these packages, all the relationships, but I will not be able to say why this package is here, why this vulnerability is here. Or I should not be putting that responsibility to fix that particular vulnerability to the developer. So we implemented some algorithm to actually segregate vulnerabilities from commons. So basically this is how it is. So here we get the path. So this is the full path how a vulnerable package was introduced. Now if you see, this is the main service and that is the vulnerable package. Now it is imported being through a chain. Now if you take this, we actually iterate backwards from the vulnerable package and we try to see where the package namespace changed. So here, this is some outside package. It could be some publicly available package. And when you jump ahead, then you see that it is a company internal package. So this has to be marked as the responsible person who actually imported this vulnerable package. So the ownership clearly remains with the platform team. Like we can actually segregate. We can actually say that the chain ends here and this part is under the developer. This part is under the developer. And whatever comes here is the responsibility of the platform team. Next question was prioritization. So how do we prioritize what vulnerabilities need to be fixed first? So yeah. So for us, CVSS score did not make sense completely because that indicated criticality, but it did not showcase is the vulnerability reachable. Like let's say it is in an internal service or it is buried deep. So will that be actually exploited? The chance of or the probability is very less. So that CVSS did not make sense fully. But then another case was the exploitability. So it needed that certain configurations to be exploitable. So all those things. So due to all these cases, we wanted to not prioritize based on the CVSS. So we decided that we'll fix public-facing services first. We could also use further prioritization steps like the EPSS score. Or we could actually do the reachability analysis to detect what packages needs to be fixed first. Yes. Yeah. So how did we implement that? So we have the API gateway and we extract the list of public APIs. And from the repository we get the SCA vulnerabilities. We do a match and we identify the public services. And the SCA issues arising from the public services will need to be fixed first. Yes, so we built some dashboards based on that, focusing engineering pods. And we also gave the developers the right actionables, excluding the commons packages, excluding all the things which we saw before. Yes, so we are actually building more features, like providing the secure upgrade versions. Developers would we are actually dumping the vulnerabilities, like you need to fix this, but we are not giving which vulnerability or which version they should be fixing or upgrading that package to. So that was also a missing information. Now we are actually giving that data also. Then open source alternatives. So there are some packages which does not have any new versions to upgrade to. So we are actually solving for that also. Yeah, we are also building an AI-based IDE plugin in which the developers actually get alerts when using some vulnerable version of packages. So yeah. Takeaways. So visibility is the first step. Like you can't actually secure what you can't see. So we actually need to build visibility, like we did the SBOM, right? Similarly, we need to build visibility so that you will get the full view and see what needs to be fixed first. Then there is no one size solution that fits all. So, and solutions evolve over time. Then, yeah, stakeholder alignment is crucial. And security must work for engineers and not against them. Because we should actually complement, we should help them to solve the issues first. And we also believe that open source problems must be solved by open source. Cool. Yeah. Any questions? Sorry. We actually use this in multiple companies. Like we have deployed the solution and it is working successfully so that they are using it. They are happy with it. Yeah.
Let's talk about the reform.
Correct. Huh.
How the reform map it to vulnerabilities.
Okay. Let me answer that. So here, if you see, we get the SBOM here, right? Using the CDXGen. And here, scan code. Scan code is actually a public tool, like it's an open source tool, which you can use. And it has mainly 3 functionalities. So in the find vulnerabilities section, we send the SBOM to some open source vulnerability database. Like it could be the CVD NVD database. So there are multiple databases that you could use. We also have this OSV, which is maintained by Google. So that will have the multiple list of vulnerabilities that are being. Exactly. Yeah. If you actually pass the package name you saw here, right? Some package URL like this, you get the list of vulnerabilities that are associated with that. Yes, I'll answer that as well. Yeah. So here let's take this thing. Let's consider this thing. And that is the vulnerable package. So as a developer of this service, I won't have visibility on what is going underneath. I actually need to upgrade this package to a safer version. So that is how we can actually solve the first level. We should be upgrading. You can also hard code, like there are multiple options. Like you can also hard code what version needs to be there, but it would lead to compatibility issues and many other problems. Yes. Correct. Yeah. So that happens due to Maven. So if it's a Java microservice, right? There would be multiple packages which are dependent on this particular vulnerable one. So you need to actually build and figure out did it fix. So that is a problem which we have addressed internally. Yeah. Okay. So yeah, that is one of the upcoming feature that we have. Yeah. Yes, here. Open source alternative suggestion. So we are actually planning to implement something based on the change logs. So we need to suggest some version which is safe, but also maintains all the functionalities of it. So if there are no versions available which are not vulnerable, we can't actually do anything. Like we would need to suggest an alternative version. Going and fixing it manually in the code won't be a proper solution because it's not maintained, right? So the first step would be to do that. Yes, we need to wait or we need to suggest an alternative. Yes, correct. So we are actually experimenting it in-house, and once that is ready, we will ship it to public, open source. Yes. Correct. That is an issue, something which we can't do much about it. Yeah. Anything else? Yes. So they are a closed source product, right? This is completely open source. Like anyone can contribute, anyone can see what is happening underneath, and we are free, of course. So that's a good competition, right? Correct. This is similar to that, but we will have this is directly plug and play. Like you can simply go and use it in an organization. Because if you see the architecture, right, we have complete integration with Jenkins, and we also have a dashboard and whatnot. Okay. Yeah, that is something which we have not solved yet. So packages without a package manager, we won't be able to get the exact versions and all. But through Docker, you can get, installed packages list you can get. But that, correct. Yeah. Yes. There are multiple problems when doing legacy code. But recently, I think Ruby and all, CDXGen has got support and all. So maybe you can try using that. Cool.
Just adding upon something, we have to think about the
Correct.
I mentioned that you have a dashboard, right? So we're doing something in-house. So one of the challenges we had coming up with the good metrics. Leadership expects good metrics at this point. We are moving to a where we have to go. Keeping that in mind, the maturity of trying to do what should be called clearing metrics.
Okay. So, I'll answer that. So, right, internally we have built a dashboard that will actually show the actionable packages. So, leadership or developers won't care about the number of vulnerabilities or number of packages to be fixed, right? They would need something which is way better. So, So, what's the other direction? Let's take this example itself. So we actually would have tens and hundreds of paths like this, right? And showing how many, this vulnerable package would be introduced through multiple paths and all. So showing the vulnerability and number of CVs, number of the severity and all won't make sense to a leadership. But if you showcase the number of actionables, like number of packages or parent packages they need to upgrade, that is the number that essentially boils down to the number of things that are pending on the developer, right? So I think that would make a better sense there. Are you building something in-house? Cool. Interesting. We'll catch up. What is? Sorry? Sure. This is in a stage where everyone can contribute. So this was open source like 3-4 months back, but we have been using in our organizations since long. Yeah. Correct. Yeah. Yes. Correct. Yes. Correct. Actually, we faced a similar situation while building itself. So we started with the Docker image, right? So then we thought that the Docker image, it is very difficult to handle for developers also. Even if they fix, something vulnerable would come up again next quarter. So that is very correct. So we also had faced a similar situation, and we actually started prioritizing application level SCA issues. So that is easier to fix. that is actually more priority because it's a direct HTTP call that would cause something more dangerous. So we actually changed the prioritization based on that. So yeah. And we can have multiple layers or multiple other protections that we could use, right? For especially binary vulnerabilities are introduced by these packages. Huh. Yes, that would reduce the count of the packages and it would drastically reduce. Yes. Yes, it would be difficult. Yeah, we have that. Like, we have our DevOps team who would actually supply these base images. So they ensure that there are no vulnerabilities or there are very less vulnerabilities shipped. So developers are actually using the images provided by them. So that would be minimal image. Yeah. Okay. Correct. Okay. 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 Got it. So your question is that there is a package and there is a function which is vulnerable, and that function is being used by some package. Yeah. So we have to actually face, like, there is something called reachability. Have you checked that? Yeah. So if that function is reachable, or if it is a reachable function according to that tool or logic, then I think it's better to prioritize that. So you have already done that reachability part, right? Checking part. So it's better to fix all the reachable issues beforehand. Yes, there are tools available, like free tools available in the market. Like, I think it was Atom. Yeah. Anything else? Any questions? It is mainly written focusing on Java and Go. But others might also work. Yeah.
Do you have the capability to build response to other languages?
Yes, we are using CDXN internally. So that means CDXN actually works on many languages. So that would also support this.
Do you have integration for the open source libraries, open source vulnerability database?
Yes, we have integration with OSP. Yeah.
Any other questions?
Cool. We got a good number of questions.
Yes, you answered them really well. So please give him a huge round of applause, Yadu Krishna.